Good evening, everybody. Can you hear me?
Yes, Prof.
What is happening? I'm only seeing one or two students here at this hour. What's happening?
You are still stuck in Prof. Kachuku's class.
I still hasn't completed. Well, or maybe he should be. I mean, probably somebody should let him know. Maybe he doesn't even know that the time is up.
Okay, I'll let you know.
Or maybe the class rep. If he knows that the students are going to attend another class, maybe he doesn't even was thinking, might not have been thinking that they will be attending another class. Okay. We can start the class now. I hope you can hear me loud and clear and also see the slide I'm sharing with you.
Yes, Prof.
Okay. Last week, we started looking at the database environment and we went through some definitions and certain concepts. trace some history about file systems and so forth. Today we would continue looking at the database environment. As I told you last week that the first three classes, lecture 1, lecture 2, lecture 3, would definitely be fundamentals, at least to help those who have not done a course of this nature. So today we would continue with database environment, and I'm sure we can finish that today, which will pave way for us to look at relational databases next week. Okay, having said so, I'll go straight to the material we are using, and then we take it out from there. So I shared the textbook and the course outline, I think the term paper, and also some notes on data warehousing. There are a number of slides that I shared. As I said, the same. Those who have the mic on should put it off. Herbert.
Hello, sir. Please is off.
Okay, so when we met last week, we talked about the file system down to even looking at the traditional file system, its limitations, and then we went to look at the database approach. We discussed the advantages, the database approach. We talk about its advantages, and I think we ended it up by looking at the components of a database environment. There's hardware, software, data, procedures, and people. All right, so I think we didn't talk about this, but this one we can do it in the next 3 minutes. The roles of database, the roles that are played in the database environment. So we have database administrator, database designers, then we have application developers, end users. So these are various roles people play in the database environment. Okay. You can read about what exactly they do. If you are a database administrator, what work do you do? Database designer. We'll also look at the application developers. I know some of you are already database. Some of you are already database developers. Some might be application developers. Some are designers. But I'm sure by the end of this course, based on the work that I'll be giving you, the project that I will be doing, you will be putting your hands to do some work regarding database designing. You'll do some work there. Of course, you'll do some work also as an application developer. So you will develop a simple system following all the best practices and concepts that we have learned. Please, just a minute. Okay, so you'll be learning database designing, and then of course you will also be putting your hands to some development around the database, and then some small front end, at least such that at the end of this course, practically, you can put something together and develop an application using even up to using some advanced tools and concepts. Okay, so having said that, of course, the advantages of database management systems are here listed in this table. You can see we even mentioned them the other day, data consistency. Once we have data consistency here, the flat file system, we have data inconsistency. Where we have data, we have removal of redundancy. The other side, we have redundancy. So that's all of them are advantages are all listed here. You can see data sharing is improved and so forth. Now, I think I may need to make this statement extremely clear that in my class, I don't tolerate this kind of noise. So please, when we come for lectures, put your mic off. It is very important. Put your mic off. I'll be taking note of those who are disturbing the class. So please. Okay. Now, there are also disadvantages we saw the other day that database management systems can be complex, performance degradation, cost of conversion, etc., etc. And that led us to the end of that chapter. I recollect that I advise you to review the chapter, try to attempt answering these questions, review questions, and these exercises so that you can be sure you thoroughly understand the chapter. Now, today we are starting a new topic, which is database environment. Okay. Database environment. Okay, so let's quickly look at the objectives of today's lecture listed here. But before we move on to that, if you have any question, comment, suggestion, or you want to clarify something, you can do so. Erasmus, you are disturbing the class. Okay, if you have any question, comment based on what we learned last week or something relating to the database systems course that you are offering and I'm teaching. If you have any question, comment, suggestion, maybe you went home and something came to your mind as you were studying and you said, well, when we come for lectures, you clarify it from the lecturer. If there is something like that, you can do so now before we delve into today's lecture. Okay, since it means that so far, so good. Therefore, I can continue. Okay, so now, you see, anytime you want to understand a course very well, try to understand the basic concepts. Here we want to look at the architecture and the environment of the database itself before we begin to delve into individual topics. So today we are coming to look at the three-level database architecture. Then we will see the external, conceptual, and internal levels. In actual fact, these all form part of the three-level database architecture. We will discuss each of these, the external, the internal, and then the conceptual levels. And then we will link it to how we can explain it along with the data. Okay, we would speak a little bit about data definition and data manipulation that we mentioned last week. Then data models, various types of data models will be mentioned, but not discussed into details now. Then we would look at the functions of database, the functions that database management systems provide, the catalog, components. Then we will spend a bit of time to look at the client server and two-tier, three-tier architectures of the database environment. Then finally, we will look at the functions and uses of transaction processing. So these are the things we are coming to cover in just this class. You know, when technology, any technology that takes off, one of the first few things that is done is to design its architecture. Its architecture. So today we want to look at the architecture of the database systems. There were institutions, organizations, committees, conferences in the past that worked on developing the architecture for the database. Maybe those Daniel Sosu, put off your mic. I just will need to say this again, that those who are disturbing the class portray to me something. That one, you are not even paying attention, you only switch on the machine, you are not taking the class serious. And after this last warning, those who would disturb the class will be penalized. So take it from me. From now going, I've given, I think this is the third warning that I've given. I'm dealing with mature students, I know. I'm not dealing with undergraduate. For undergraduate, we all know the way they behave. But for mature students like you, I expect that you would exercise some level of discipline when we come to class. And there is no way I would tolerate this kind of behavior in class. Okay. All right, so we're talking about the architecture that once a technology comes up or is about to come up, an architecture is developed to let us know various components, various parts, and how they interrelate. So databases, when databases were developed, an architecture came out from a committee that developed or proposed an architecture, which is, what do I say it, implementation independent. What it means is anybody who wants to develop database systems, or any organization that wants to develop database systems like Oracle, VB2, and others, those companies will need to follow that standard so that we can maintain a common standard. So a committee was formed, an American National Standards Institute, together with the planning and then requirement committee, SPAC, developed or proposed an architecture. And this architecture is made up of 3 levels. So we have a level, the first level, the highest level, which is external. Then we have the conceptual. Then we have the internal level. So you can see the way it looks. So when you look at this, the highest level is the external level. We have conceptual level, internal level before how the data is physically organized on disk at the lower level. Okay, so we would just take a quick look at what goes into each of these levels, or what is contained in each of these levels. So the external level, so you will see the user's view of the database. You see, when you are working on a database, the views that we normally provide, or the interface that we normally provide the users, is not the view or the internal view of the database. So the users are provided with a certain view, and the view that they are describes what is relevant to each user. So you see, we can create what we call even customized view for even groups of various users that perform certain roles. So this level describes that part of the database that is relevant to each user. That is the external view. Generally, the user interfaces through even views and other database concepts. Okay, so that's briefly there. We'll be looking at the details as we go along. Now, the next level is the conceptual level. That is the community view of the database. This level describes what, so take note of the word what data is stored in the database and the relationship among the data. So this is one of the areas we will be spending some time, maybe in our 4th class or so, to look at what data is stored. Okay, this level, being able to model data at this level, is very critical. And this is the level that takes you up to doing normalization and then being able to create appropriate relationships among the relations or the tables. Okay. It made up with, it can be broken down into the 4 points listed over here. That is entities, their attributes, their relationships, the constraints that we put on the data, the semantic information about the data, that's the meaning of the data, security and integrity issues regarding the data. So all of these are defined at the conceptual level. As I said, we'll spend a lot of time on this. Now the next level within the architecture at the internal level, that's the physical representation of the database on the computer. So as you can see that over here. All right, the physical representation of database on it. This level describes how the data is stored in the database. So take note of this. One describes how, another one talks about hot data. How should the data be installed, or how is it installed? That's the internal level. It has to do with quite a number of things that we will also be seeing in subsequent chapters. So the internal level, that's storage engine, storage space allocation, indexing, what do we call it? Size of the data, record placement, data compression, data encryption, and so forth, and so forth. So they fall under the internal levels. Okay. So now we have described, based on the ANSI SPAC architecture, we have described briefly the three architectural elements of database systems. In fact, each database or databases that have been developed, they follow architecture similar to this. So when you take, for instance, Oracle, you will see that Oracle, they all follow the same architecture because it's a standard that has been developed to be followed to maintain standardization in database systems development industry. Okay, having said this, I will pause for a moment. Maybe there is a question going through somebody's mind. If there is a question going through your mind, or you need further clarification, you can please raise your hand. Feel free and ask. Don't be scared in my class, even though I will maintain discipline. They are all for our good, such that we can benefit from this class. So I normally try to maintain discipline. Okay, Isaac.
Prof, please, in the image that shows the ANSI SPAC,
Yes.
the database, there was the internal part, and then below the internal part is the database, which has the inscription, the physical storage of the data. But you explain it as being part of the internal part of the database. If you can explain that bit a little bit for me.
Actually, yeah. Can you view the image from there? I'm showing it again.
Yes, I can see it.
Actually, the internal side, if you see the definition of the internal, which we have, the physical representation of the database on the computer, you see. So over here, the architecture is only 3 level, not 4, 3 level. But I think that those who drew the diagram wanted to tell us that the databases are part of the internal, so they brought it also over here. Maybe.
Oh, okay.
And they just wanted us to show us that the database is generally what the actual physical database, how data is stored, is part of this. But the diagram should have been a bit clearer. Otherwise, somebody would take this to mean that there are 4 levels, that there are 3 levels.
Yes. Thank you, Prof.
So okay, the definition clarifies that it's just the physical representation of the data. So it involves the database itself. Okay, that's fine. I think it's a good observation.
Hello,
Any
sir.
other? Yes.
Prof, good evening.
Go ahead, George. Good evening.
Yes, sir. Sir, please, the conceptual level, you said it looks at how it explores things like relationships between the data and things like that. I was wondering if it's linked or related in any way to conceptual framework as we use in research.
That's interesting. The conceptual framework in research is I don't want to talk about that much here. You develop or you perceive some what we call constructs. Let's say malware infestation. Then you also perceive data on disk. These are
Yes,
two
sir.
constructs. Then you want to see what's the relationship between malware infestation and data on disk. Maybe you foresee that there should be some relationship between the two. You see, so in your concept, your own concept, then you propose that there is a relationship between malware infestation and data on disk. You see, so in that case, it is your concept now. That's why I say conceptual framework. Your concept, you conceptualize it. That there might be some relationship between the two. So it appears that they are talking about something close, but then over here, conceptual framework. This conceptual framework is a laid down architecture that we use to model databases. So you will see that because it's conceptual, it also comes with relationship. You identify entity, attributes, relationships among them, constraints on the data, and then so forth and so forth. But though they appear to be talking about identifying what do we call it, objects and creating relationships, they appear to be the same, but the concept here is different from the one we use in the research.
Yes, sir.
Okay. Maybe
Yes,
as we
sir.
are
Thank
going
you.
along, maybe better understanding will be coming into that. Okay. Okay, there is a hand on. What was the name? Gonja, is it Gonja or what?
Is
What's
Goa.
the name?
Goa.
Goa, okay. Gonwa.
Okay. Yes. I would like to know the conceptual level is like the law you need to follow to make the database.
Yeah, the rules.
Okay. Thank you.
There are certain rules. Certain principles. If you don't follow them at this stage, even the conceptual level is, to me, the most critical. If you are not able to do this properly, then your database will be faulty, or it may end up containing redundancy, inconsistency, things that we were trying to avoid will just come into your database. So we'll be spending time all of these listed over here are going to be treated as, are going to be part of a chapter that will be doing how do I go about doing a conceptual level, how do I model a data using principles and concepts, accepted rules and best practices, and then so forth. So we'll be delving into this and we'll break them all down, and then we'll do a model, and we'll learn the best practice as to model the database. So there are a set of rules, actually. You are right. Set of rules we should follow. Okay. Okay. Now we can, I hope you are okay with that. We can continue, is that not it? Okay, so we will continue at the point. I would again pause for clarifications and comments and suggestions as you may have it. The general description or the overall description of the data. In fact, in the database, we have a lot of data elements, tables, triggers, and all so many objects within the database. So the overall description of the database is normally what we call database schema. So it involves even the domain, the data items, the values, the attributes, all the catalogs, and all of them. We refer to all of them as database schema. So having said we have database schema, simply the database overall description of the database is what we have the internal level, external, internal, and conceptual. So that's why we also ended up by saying external schema, conceptual schema, then internal schema. That means that the overall, the description of maybe this part, or the description of conceptual part, or the description of the external part. So we have correspondingly schemas for each of these levels. That's what has been described over here. We have the internal. First, we have the external schema, which is a sub-schema of the database schema. Okay. Then we have the conceptual, which also describes, you see, the conceptual schema describes all the entities, attributes, their relationships together with their constraints. Now the internal schema also is which is a complete description of the internal model containing the definition of how the data is stored, how the data is represented, the indexing, storage engine, and then so forth. That also forms the internal schema. Okay, having that in mind, this diagram tries to somehow try to make it understand the architecture a little bit more, because at the top here, for instance, the external schema, what we said, the data, the view of the database to the users. But what do users actually normally see? What they view is maybe table columns, like a staff number, first name. These are the things that they see. And then they may see the corresponding values, records, and then so forth. That's what they see. But when we come to conceptual level, where we have entities, their relationships, and so forth, we define things of this nature. And of course, we use queries or commands similar to this, which some of you are familiar with, but in any case, we'll be looking at them. So there is a relationship. This one, you come to conceptual level by this defining the attributes, the primary keys, and so forth, and then so forth. Internal levels are things that we define sometimes using index. How should the system index the data? How should it store it? Pointers, and then so forth. This may not be clearly understood now, but when we come to look at how we'll be looking at indexing, then you will see how these things are actually done. Some people think that, for instance, when a user sees records on the screen in rows and columns, people think that that's how the data is stored on disk. But the storage on disk and the visual storage engine stores data differently on disk. It is when it comes to user's view that is formatted, so to speak, in rows and columns for the user to see, but the storage is different. Okay, so this tries to clarify the architecture we saw at the top over there. Okay, okay. I can jump over this and go to languages. Last week I did mention we did mention that when you get to database environments or database approach, we have the database, then we have the database management system, and then we also have the user's view or application interface, where users interact through the database management system to the database. So we mentioned data definition, we mentioned data manipulation, and I gave you two more: transaction control, and we also mentioned data control language and transaction control language. So we just mentioned them here. Two of them are mentioned here. We will be familiarizing ourselves with data definition. Then we will also do so with data manipulation. We will do a full chapter, about 3 chapters, but we will not do all the chapters on transaction control. Then we will also look at the data control language, maybe 1 chapter. That is about the database security, basically. Okay. So data definition are the commands that we use to create the objects or modify the structures. So we use it to create or modify drop objects, and also sometimes how do we create integrity constraints. The data manipulation are a set of commands that we use to, of course, the word says manipulation, set of commands that we use to update, insert, delete, retrieve. So you will see them listed over here. There are a set of commands that will do that. Since we are not discussing commands now, we only say a commands to insert a new data into the database, modify, edit, retrieve, then delete the records from the database. Okay. Then we would, fourth generation, you can read the fourth generation languages. Over time, the conceptual level that we saw earlier on, the conceptual level that has to do with entities, attributes, their relationships, constraints, and so on. There were certain models that came up as to how that can be done, and then be represented on the physical disk. So certain models came up. Some time back or earlier, databases were using what we call the hierarchical structure. And then we came to other structures down to relational database model. Then these days we have object-oriented database models and then so forth. But relational database models become very popular and are still being used in many large databases until a few years ago when other models were developed for data warehousing. As dimensional models were developed for big data environments and for data warehousing and others. We will be looking at some of these models, but in this chapter they are just been mentioned. But the popular ones we will be looking at the relational, then we'll look at the dimensional models as well. So when we talk about data model, we are talking about an integrated collection of concepts. Look at these concepts so for how we will describe and manipulate the data, and then how we will create a relationship, and then the constraints among the data. So you will see straight away that this side is talking about the conceptual level, and this is where the work is. If you are able to do this one well, then your database will stand the test of time. Okay. The data models generally will have three different components, or it's made up of three components. The structural part, which consists of a set of rules according to which databases can be constructed. Then the other part is the manipulative section, that is defining the types of operations that are allowed on the data. Next week, I'm sure we'll be seeing the type of operations that will be allowed on the data when we are coming to do the, I think, this calculus and algebra. We will see the types of operations that can be allowed to operate on the data. Then, normally, when we get the structural part, the manipulative part, we also have the set of integrity constraints. Constraints are limitations that we put on the data. We will be looking at various constraints pretty soon. This allows us to keep the data accurate. Okay, so these are the various components of a data model. So whichever data model that you find, whether it is relational, it is network hierarchical, object-oriented, or dimensional, they will all follow these three components. We'll be seeing these things, actually, the commands, and see how they are done as we go along. Okay. Okay, we'll be discussing all this, so I don't want to worry myself with them now. Okay. So you will see the first one is relational data model, which we'll be talking about a lot. Then we have network data model. This was quite among the first few data models that came up. You can read about it. Then we have a hierarchical data model. You can read about that one also. But our attention will basically be on relational data models and object-oriented data models, as well as the dimensional data models. Okay. Now I want to quickly bring to your notice the main functions of a database management systems. You remember the first chapter we talked about the advantages of database management systems. But now we want to talk about the functions. What functions do they perform? So we listed a number of them here. I don't know whether anybody has seen this name before. COD. Anybody has seen that name before? And who is this person? Is there anybody who has seen that name before? His first name is John. John COD.
Yes, please.
Yes, there is a hand up. You've seen it before, that name.
I've seen it before.
You've seen it. Who is it? Who is that man?
I think is the first person that brought about a relational database.
You are there. You are there. You are right. You see, I think you've been reading textbooks. Those who don't read textbooks, they don't get this kind of information. No. They only know about the query, but they don't know about history behind things. You are very right. So this guy was a mathematician. He developed a lot of mathematical concepts that are behind the whole databases. The database we are learning right now is actually mathematics, so it's built on mathematics. So when you begin to analyze queries, for instance, when we come to query optimization and all this, and relational algebra, pretty soon, maybe next week or so, when we begin to see relational algebra and calculus, you see that everything is mathematics. And this is a man who did, this mathematician did a good work by bringing up relational databases. And those who did all these things, they do not even benefit from it much. But then we are rather benefiting from the work they did. So John Cott listed 8 services that a full-fledged database management system should have. So we will see what he has said, that a full-fledged database management system should have the following. Should have the ability to store data, retrieve, and update. So it should give users interfaces or the ability to store, retrieve, and update database in the database. Please remember that we are talking about database management system, the functions. It is different from the database. So this gives you, this an intermediary sort of component or model or software that falls between the user's interfaces or application software to the database. So of course, since it lies in between the database and the application software, It should allow users to store, retrieve, and update data. It also provides users with accessible catalog, generally some kind of metadata. It would allow users to catalog or descriptions of data items and so on. Users must be able to store them and have access to them. Things like names, types, sizes of items, names and relationship constraints and all sorts users must be able to store them, or database management system should be able to keep them in the catalog, which we normally call metadata, which means data describing data, and many more other things. You can read all that. Relational database management system should also be able to provide us with transaction support, which is the mechanism that ensures either that all updates corresponding to a given transaction are made, or that none of them is made. People develop systems and they don't make use of transaction management techniques. If you write a computer program and you don't know some of these things, how to handle them, you may have single-sided transactions posted, and it can create a lot of problems. Seriously, a lot of problems. For instance, computer programs execute one, so to speak, technically speaking, one line at a time, one statement at a time. So if you have two statements, one should carry out debit, another one should carry out credit. And the computer executes the first line, and an exception has occurred. Let's say error, which normally we don't call error, we say exception. Maybe some technical network fault or something in the second line is not executed. Immediately, if it saves the first line, that means that you have single-sided transaction, which is completely wrong. Completely wrong. So database management systems should provide us a facility where such a thing should not happen. Maybe you have 100 lines. All the 100 lines, maybe when they execute to the end, before we will say that that transaction is over. Otherwise, if it executes to 50 and an error occurs, it should roll back to the beginning so that the database will remain in the consistent mode. So it doesn't go into inconsistent mode. So relational databases should provide this. They should also provide us with concurrency control in such a manner that multiple, multiple users can use the same object at the same time. And then at the end of it, the results that maybe some are saving, others are retrieving, and so forth, at the end of it all, the data objects will still remain in a consistent mode. Otherwise, if somebody is saving one, somebody is retrieving from the same data item and all that, if database management system cannot provide concurrency control, then the database will be messed up. Okay, another one is recovery services. If an event occurs or a damage occurs, we should be able to reconstruct the data, or we should be able to recover. We should be able to recover from damages. Database management system should also provide us of authorization services, the login, privileges, and who should have access to which object, and so forth. Of course, it should have support for networking. I think some of you are just from the networking class. Databases should support network, is capable of integrating into network softwares. Then integrity services as well. That changes to data must follow certain rules as integrity. Then services to promote data independence. This one just portrays this one portrays that changes to the underlying database should not affect your application program. So if you make changes to the underlying tables and so forth, it should not throw off your application program. It should still continue working seamlessly. Then there should be utility services like backup, restoring of files, and maybe doing how do we call it, integrity checks, reallocation of files, garbage collection, system monitoring, statistics analysis to check how the database is doing and all that. So the utility services must also be part of database management system. So when you want to develop a database management system or you want to evaluate database management systems, you should see these things, these key functions in there, which is critical. There are about 10 of them listed over here. Okay, having talked about that, I will again pause for a moment if there is any question that somebody want to pose regarding what we've covered before we now delve into the components. We can do so. Okay, since we don't have any question, it means so far so good. Okay, there is a hand. Go ahead, please.
I would like to know the difference with concurrency control services and authorization services. Like same thing.
I don't get the question clearly.
I would like to know the difference because you say that concurrency control services manage
concurrency. Concurrency. And
authorization services.
Authorization services.
Authorization. Okay. Concurrency is, in database environment, one thing that makes it very appealing is that there can be multi-user system. That means several users can manipulate an object, even a single object in the database. So concurrency means that several users manipulating the same object. They are concurrently using the same object at the same time, which ordinarily should create problems. Because assuming that, let's say you have money in the bank, and then maybe it's 100,000, and then you write 2 checks, one of them 100,000, another one 100,000. Then you want to fool the teller, so you give these checks to 2 different people. One stands on one terminal or with one teller, another one, and then you try to synchronize things in such a manner that they will do the posting at the same time, such that the first person, if they all happen at the same time, then immediately this person will withdraw the 100,000, another person will also withdraw the 100,000. Because they all will open the system. Let's say they all click the same time. The two tellers, they see the 100,000 is in the account. They all click again to credit or debit at the same time. Then you see that at the end of the day, both of them would be taking away 100,000, 100,000. You see, so this was a challenge. So there is this concern when you are developing database management system, but ensure that such a thing cannot occur. So that is what we call concurrency. Concurrency management. You manage it such that even though many people are using the same objects, none of them would turn the database or the table into inconsistent mode. So there are protocols we'll be learning, concurrency protocols, two-phase protocols. So many protocols we'll be learning as to how such a thing could be prevented. That is what we mean by concurrency management. That even if one person is updating, another one is retrieving and so on, they will not all read, some will not read dirty data and then so forth. So it's a topic we'll be treating later on. Now I think you were talking about the other one, authorization. Authorization is about whether you have the necessary privilege to access that data. Whether you have the necessary privilege or access to that object. You will see that these things happen everywhere in many organizations, depending on your role. The database is set up such that you cannot have access to something. Even right now at the University of Ghana, you don't have access to certain things that I have access to. Similarly, you also have access to certain things I don't. So you are authorized to have access to certain objects. And database management systems should provide us with facilities where we can do such an assignment or setting up roles and privileges to various users. So that is the authorization. I don't know whether you are fine with the explanation.
Yes, it's good, Doctor.
Okay. All right. Any other? I can take one more before we continue. Otherwise, I will just move on. Now that we have talked a lot about the functions, it will be a good idea to look at the components of a database management systems. This one we have very detailed architecture about the database management system itself, the components. So this first diagram, when you look at this first diagram, it tells you a number of things. That you see the middle here, where we have database management system with various functions. We've mentioned the functions earlier. So these components are performing all the 10 functions that we raised over there. You see that we have data definition, compiler, dictionary, database management, query processor, database, data manipulation language, preprocessor, programming code. They are all the components of the database that are providing services, that the functions that we have mentioned earlier. The database management system also provides interfaces to various users. For instance, end users, they issue queries and so forth. And most of these queries are embedded in application programs. So you click a button and it generates some reports and those things for them. The database administrator will be creating the schemas like we will be doing. Very soon we'll be creating schemas and then model databases. So we'll be doing this one. We will also be looking at queries. So we also know about what users could view, because in any case, we develop the systems for them. And then it should also give you facility to write your own application software, maybe using C#, PHP, ASP, and many other tools, programs, so that the programs will link to the data through the database management system to your underlying database. Okay, so this gives us various components. You see that another major component is access method. I think that's the question that somebody asks right now. Authorization. How do we access the database? Then file manager. Then system buffers to keep temporary files so that you can speed up the retrieval of records to the users. So as a whole, this is how the general overview of the components of a database management systems look like. This can all be broken down. We can take maybe query processor and break them down, database manager and break them down. So it is now our duty to understand the linkages among them, 1, 2, what each of the component here does. So there are definitions as to what these things really will do. So when you come here, you'll see we have taken query processor. What does it do? We have it here. So you see the query processor here. What is this function? It's a component that transforms queries into series of low-level instructions directed to the database manager. Similarly, we take the next one, database manager. Then we see what it does. It's also here. Okay. The file manager, what it does, manipulates the underlying storage files and manages the allocation of storage space on disk. You can see that one also. So what I'll be leaving with you is that you will study the diagrams here, then understand what they do, the components do. Data definition compiler, of course. Since we know what data definition is, the compiler, what does it do? Of course, it will enable us to create objects and its metadata and so forth. Catalog manager will allow us to save maybe certain commands like triggers, store procedures, and then metadata and so forth to store them. So this side, you can then read, you see, we even have authorization control. What does it do? It gives us maybe facilities to set privileges as to who should have access to what object. Query optimizer to enable us to quickly fetch records. Or we optimize queries, or it optimizes queries in such a manner that records can easily be retrieved without performance bottlenecks. And we talk about transaction already. You remember we just talked about transaction. I tried to explain it. So there must be a component. Transaction manager takes care of transactions. Scheduler, recovery, how we can recover from faults. And then so forth. Read about that also. So you will see that these diagrams are the write-ups on these diagrams are presented over here, one after the other. When we were even looking at the conceptual model, you remember we talked about integrity constraints. So there must be a component in the database that will take care of how that is set. So we have here integrity checker and so forth. Okay, so that the text below explains This diagram. This diagram is important. When you take this vendor independence, but if you take maybe Oracle and you want to look at the Oracle major components, they follow the same thing like this. If you take DB2 or SQL Server, they follow the same kind of thing like this, because these are the things that are needed there for them to be able to meet the 10 functions of the database management system. Okay, having said so, I will pause for a while and take a question or two. Then we'll continue to look at the some tiered architectures, database architecture, the tiered architectures. Okay. Okay, now we don't have any question. Before we continue to look at the multi-user, I did mention earlier that databases are multi-user. If they are not multi-user, they will have been useless, because that means not many people, one person can only use it at a time. But they are multi-user. Is there any question on the floor?
Yes, I have a question.
Okay. Go ahead.
Let's say we are designing a database, for instance. Must we include all these 10 functions of DBMS, or our function we are going to be will depends on what our database is going to do?
We can't hear anything.
Hello?
Actually, we can't hear you. Your line is not clear. Your line is not
Hello,
clear.
can you hear
Maybe
me?
you can come. Yeah, it's better now.
It's better.
Okay. Let's say we are designing a database and we have all these 10 functions. Is it a must that we should include everything, or including a particular function in a database depends on what your database is supposed to do?
You see these components we are all talking about, they are already in the database management system. So what you are doing, your design and modeling and so on, these components are already there that will facilitate your design. So if you learn the command as to, let's say, how to set authorization, once you use the command, authorization control model will take over and perform it on your behalf. So these things are not things that you are coming to, so to speak, come and do, or what do we call it, design yourself. It's already a software component. That as a database management system is a software. But then it enables you, this software with various components enable you to implement your database on top of these things. For instance, if you want authorization, maybe you want somebody to have access to viewing the balance. If this component were not there in the database management, you wouldn't have been able to do so. But it's already there. So you only learn how or which command can I use such that this authorization control model can take over and create that kind of facility for me. So these things are already there, but you need to understand that the database management system that you are using or that are there have these components. That is all it means here.
Okay, thank you.
Okay. I see another hand up. Oh, okay, maybe the hand is lowered. Okay. Okay, so now Having addressed that, you will be going to the next one. Now we look at some multi-user architectures. Multi-user architectures. Some architectures that database management system over time or have been provided such that many users can use databases at the same time. Okay. But before we do that, let us take a 5 minutes break. By my watch is 8:28. So we'll return by 8:33. We'll be back to continue. So let's take 5 minutes break. And then we'll come back to continue.
Hello, Prof. Please, I wanted to ask a non-related question. Is it allowed at this time or at the end of the class?
He said we are on break, so when he comes.
Okay, thank you.
I think his microphone is muted.
No, he said we
Okay.
are taking 5 minute break, so you'll be back.
Yes, we are on break, but his microphone too is muted. So okay, I don't know if you can hear.
Yeah, he muted because we are on break.
All right, so we can continue from where we left off. But I saw a hand up at the time we were going on short break. So if the student still asks a question,
Yes, Prof. But the question was unrelated, so I wanted to know whether I could ask it during the break or I should wait after the class.
okay, then maybe when we are done, when we are done, you can ask the question.
Yes, Prof. Thank you.
Okay, all right. Any related question? Okay, so we come here and then we look at the various architectures. The first one is this architecture that we call file server architecture. Normally residing on the local area network. It used to be quite popular when databases, this kind of databases started. And several years ago, we meet. It's not too popular now, but its variations have cropped up again. That we are calling is it thin server or something kind of. But this file server holds files required by the applications and the database. Okay, it's normally stored on the local area network. Then the applications and the database systems run on the each workstation, requesting services from the central server. Sometimes they call it teleprocessing topology. So you see how that looks like. We have the file server, then terminals having access to this. Okay.
Prof,
Yes.
is is it a thin client sort of database?
This one came back first, where we have
Okay.
those times when this one came, we were using mostly the flat file system that I described last week. The flat file system that I described last week.
Yeah.
So I remember when we completed I completed my first degree, that computer science, some years back, several years, of course. And then we were working with some companies. This is what we were using. You will see one big machine that they bought. Some of the machines are bigger than a fridge, a deep freezer, or a fridge. Oh, big. You are even scared to go to the computer room when you see the machines, and then they will write there that out of bounds. So those sort of create a scare around those computers. And then we have some terminals. And those days, the terminals were dump terminals.
Dumped.
And then the file server was basically flat file system where we issue queries and then so forth, and then we retrieve records from the flat file system that we talked about last week.
So, bro, my question is, hello. So I'm asking,
go ahead.
if the thin client that we have nowadays is what has replaced the
Interestingly, when this architecture came, and then it was later criticized, and when we came to databases and so forth, and now we have come back to the thin client, and we come back to this same architecture.
Yeah.
But then The difference now is the thin client is not necessarily on the local area network. Two, it could be local, but two, it now uses appropriate databases, not necessarily flat file. Flat file systems are almost out of the system. Flat file databases are out of the system. To a large extent, they are still there because we can still save to flat files, and we still do. Particular log files, generally log files are saved to flat files. So it went, a similar thing has come back because the thin clients, these things are cost effective. Okay, but these ones were using flat file systems with dump terminals. Okay, so later on, this a new architecture came with the actual relational database kind of the database. You see the database here. This database, in fact, is stored on this machine. The database is on this machine. Then we connect to the local area network with now workstations and so forth, where we can retrieve records from this and back. In actual fact, all these architectures are client-server architectures. From the beginning, the first one that used dump terminals, all the processing is done by the server. The client server, the dump terminal only gives us commands that we issue to the server, and then the results that are displayed to our terminals. But as time goes on, the client server architectures begin to use intelligent terminals as well, where the terminals can also in themselves be able to carry out some processing. So when you look at this diagram very well, you see the CPU over here, the keyboard CPU, and then the screen. But when you look at this one very well, you only see the screen and then the keyboard without CPU added. So this one completely dumb terminal, having no capability at the user side, but everything is done at the server side. But here, this architecture, the clients can also perform some processing. They have memories to store, process some data here. So the processing begins to be divided into the server and then the client with the database on a server on the local area network. So queries of this nature can be issued, but I don't want us to worry about these queries. Okay. So this diagram that we saw over here is actually the client server architecture, which we normally call two-tier architecture, because you have the software components like that interact with the database could be installed on the, let's say the application software are installed on the clients over here. Of course, we have some application software which are also back-end applications, and we have them installed over here. Then the database, the structure of the database, and then so forth, they are all stored on one machine here. Application stored over here. So two-tier, tier 1, tier 2. We'll be seeing the tiers very soon. Okay, so we have tier 1 is the client machine, like these ones. Then the tier 2, they represent the server with the database. And even the database plus the database management system are all on the database server here. Okay. Okay. This diagram just shows us various forms are one client, one server, several clients, one server. Yeah. Then several clients, several servers. So these machines can mirror this. That data can be retrieved across any of the servers. Okay, so this is actually coming to tell us what resides on tier 1 and what is on tier 2. So let's see the tiered architecture here. On tier 1, we have user interfaces, main business, and data processing logic. The main business, the user interface, the main business, and data processing logic, these are generally our application program that we write to develop forms. Then under the forms, maybe we write programs as if mark greater than 90, then maybe a grade is A. All those processing logic are all installed on this. These ones, we can use any programming language to do this. Programming language can help us to write all these and then keep it on the tier 1. Then when we come to tier 2, we can put server-side validation there, which is also programming in a way. We can also use integrity constraints and all those things and put it on the data. And the database itself are all here with mechanisms to access the database. That is on all the conceptual modeling and structured database structures, objects, store procedures, triggers, functions. All of them are over here on the database. The screens and interfaces are here. This architecture is quite popular. Then you can have interaction between them. On the at the tier 1, we put in some APIs and what do you call string connection strings to be able to connect to the database. That's where we have interaction between the application interfaces and then that of the database. So this tier 2. You can read a summary of client server functions, what the client does, what the server does. The client manages the user interface, accepts and checks syntax, processes logic, generates database queries, pass response back to the user. Then the database performs this, accepts and processes database requests from client, check authorization, ensures integrity constraints, maintains system catalog, provide recovery services, and so on. So the server does this when we are dealing with the 2-tier client server environment. Later on, we came to realize that when the users are beginning to be many and several requests are coming to this one server over here, the performance degradation begins to show up. And therefore, there was this concept that why do we need to keep all these things on 2 computers, client and then the server? Why can't we have maybe a number of servers that some of these functions can be split across the servers such that the capabilities of 2 servers will be better than 1 server. The performance of 2 servers, all things being equal, will be better than 1 server. So this architecture has been broken down into 3-tier and even up to multi-tier architecture. So we can take a look at the 3-tier architecture. On the user side, which is tier 1, instead of keeping a business logic or your program logics and all the ifs and then calculations, computations, and all those things together with the client, you say no. So you only leave the user interface here and you take this one to another machine. main business logic and so forth. So you see that we now take the business logic and data processing logic to application server. So this is a server on its own. We leave the interfaces here. We maintain the data validation and database on another machine. So this is a 3-tier architecture. Of course, if we keep breaking it down, moving maybe data processing logic to another machine and so on, then we'll get 4-tier architecture and so forth and so forth. I will pause here for a question if you have one to ask. Any question on the tiered architectures?
So, Prof, hello.
Yes.
So
Go
you
ahead.
made mention of the multi-tier. I just want to be sure if this is where parallel programming comes in, where we have different cores. I just want to be sure.
Oh no. No, there is no parallel programming. We will come to the parallel as we go along. We will come to parallel as we go along. But this is not a parallel. This one, we only divide the functions across many machines.
Okay, thank you.
Okay. The parallel has to do with many machines executing a certain set of statements at the same time. So let's say I write 3 statements, all 3 statements to be executed or commands. Parallel processing may mean that one processor can even execute statement 1, another machine will execute statement 2, another one will execute statement 3, and they will put their results together. So it's different from this one, what we are discussing now. But we'll be coming to parallel processing. It's a topic on its own that we'll be discussing in class. Okay, any other question? Otherwise, I'll be bringing the lecture to an end. The notes are here for you to read. I'm sure you all have this textbook now. There are a number of slides I'll also be sending to you. I want you to start from reading the textbook. When you glance through the textbook and you begin to read the slides, they make sense. If you read the slides and you don't read anything from the textbook, it doesn't make sense. They are just points. So start reading this, and I'll give you the PowerPoints also to at least streamline your work or your reading. I wouldn't talk about transaction processing here because it's something we'll be talking about at length later on. Of course, you can walk through it if you so wish. And that brings us to the end of this chapter. Again, our advice that you glance through the chapter summary, review questions and exercises. They will help you. Next week when we meet, I'm going to teach 2 chapters. The relational model. This side is full of just definitions, so that I will just quickly come into relational algebra and relational calculus, which will give you a very good foundation towards understanding query optimization and query processing. So next week we'll look at this. Now I can take some questions, whether related or not related. Those who want to ask me some questions, whether related to what we are doing or not, we still have some time to do that. Yes, Isaac.
Yes, Prof. I wanted to join your research group on cybersecurity. I sent you a mail, but I've not.
We sent Google form this afternoon.
Oh, okay.
So go on your platform. You see the Google form. On the form, all the research groups are there. So then you choose the one you want to join. Then we'll collate all of them. Then by then I will then know all the numbers that belong to my group. The network guys will also know all that belong to their group, and then so forth. Then we start working from there. So go and complete that Google form. I hope you saw it. Haven't all of you? Have you completed it or you haven't seen it? Have you seen it?
I have not seen it, so I'll just go and check it.
It's on your platform.
Yeah, Dr. Solomon put it in earlier today.
Okay, all right.
Okay. Well, thank you very much then.
Okay, all right. Okay. If we don't have any other question or comment, I only advise you to start hard, don't relax, because as we go along, it will be becoming tougher and tougher. And workload, the work will be building up, and there will be a lot of work to do. Each lecturer will be teaching as if he's the only person teaching you and be given assignments. And therefore, don't relax at this stage at all. Once you start and you're at pace with the lecturer, that means you are on course. So end it here, and I will see you next week. Bye-bye.
Bye.